Let's prove the Bernoulli equality, which is this 1 plus a to the power n is greater than or equal to 1 plus na. There's many forms of the Bernoulli inequality. Today we're just going to prove this for positive integer n. We're going to do this once again using the mathematical induction techniques we've been practicing. So check out our previous videos for some more practice on that. First step with induction is the base case. So we're going to plug in n equals 1. That's the smallest value of n we're interested in. And in this case, we just get 1 plus a is greater than or equal to 1 plus a. And so the base case, as we've seen many times, can be pretty direct. Here, base case is complete, so we can move on to the inductive step. So we want to assume that our formula is true for some value k. K here just represents a positive integer. And then we want to show that that implies what's in green here. So I've replaced k with k plus 1. Essentially, when this is true for k, that needs to imply that it's true for k plus 1. And the rest of the problem boils down to starting with what's in white and manipulating that inequality somehow, which we assume is true, so that it looks like what's in green. And a technique we've seen before is let's start on the left-hand side and make the left-hand side exactly what we want. So here, if we multiply by 1 plus a, our left-hand side will become 1 plus a to the k plus 1. On the right-hand side, we can FOIL out, and then we can rearrange some terms here just because I'm trying to get this to look like the right-hand side of green. When I rearrange terms, I see I have this extra ka squared term. So I almost have what I want, but what am I going to do with this ka squared? So far, we've seen we can factor, we can rearrange, we can do all these tricks. There's no real trick here, though. What can I do with this ka squared? And the concept is, well, if this inequality is true, how does ka squared impact the inequality? I claim that k times a squared is a positive number. K is a positive number, it represents a positive integer, and I don't know what a is, but anything squared has to be positive. And so if that whole term is positive, I can actually say that this 1 plus k plus 1a plus ka squared thing is bigger than just those first two terms, because the ka squared was, at the end of the day, increasing the absolute value of the right-hand side. So if I get rid of it, I'm actually even smaller. And by getting rid of it, I see that I have exactly what I want, which is this inequality that I'm interested in. Make sure to like and subscribe and let me know what you want to learn next.